Now we've covered the first two fundamentals, that there is a single source of truth and that our state is read-only. It's time to cover the third and final fundamental. This fundamental is that changes are made with pure functions. When we specify how our state is going to be transformed by actions, we write pure reducers, which are just pure functions. Now, I mentioned reducers in the last video, but before we get onto reducers themselves, I just want to cover pure functions in case you're not familiar with them. So what exactly are pure functions? Well, pure functions are functions that have a predictable outcome. So when you pass in an argument, you can be sure the result is always going to be what you expect it to be. Let's take a look at exactly how pure functions work. So pure functions. Let's use the example of squaring a number. Quite a simple thing, but it really helps demonstrate exactly how pure functions work. So if we've got a function, and this is going to be a pure function called square, and it's just going to take a number n, and we're simply going to return n times n. So we're simply going to square n. Now, this is a pure function because no matter what number we pass in, we are always going to get that number times that number. It's always going to be squared. So when I pass in 4, I know I'm going to get 16. When I pass in 2, I know I'm going to get 4. There's nothing funny going on here. There's no side effects. We're not making any network requests or queries to our DB. So there's nothing going on in this function that would make us doubt the return value that we're going to get. We can be certain that the return value is what we expect it to be. An impure function might be if we take our square function again, pass in n, and this time let's say we make a call to our database with that number, and then we return n times n again. Now this would be an impure function because we're making a call to our database. We don't know what's going to happen to that number. We don't know what the result is going to be of this function. We don't know if the call to the database is going to square that number on the database and give us back the number squared already. We just simply don't know. So it's an impure function. We can't be certain of the result of this function. Another important thing about pure functions is they don't change the values that get passed in. They create new values. So they don't mutate their values. And you might have heard of mutation mentioned a few times in React and Redux, and you might have heard of immutability, and this is kind of where pure functions come in. So they don't change the value you pass into the function, they simply return a new value. Let's look at another example. So if we have a function called square all, can't spell square, square all, and we take an array of nums, an array of numbers, and let's say we simply return our array of nums dot map, and we square all those numbers. So let me just comment out the incorrect square. So this is going to return a new array of the numbers squared. So if we passed in the numbers 1, 2, 3, we would get a new array of 1, 4, and 9. So this first array would still exist, and we would get a new array. Now, if you remember back to the last video, I mentioned that we don't return the same state, we actually return a new state. So we get that state, copy it, and return a new state object. And this is what I was talking about. So we use pure functions, pure reducers, to take a value and return a new value. So an example of an impure square all function might be if we take the function square all, pass in our array nums, and then do a for loop, and we take the array numbers and each index, and then we simply set that to array numbers I times array nums I. So what this would do is it would take our 1, 2, 3 array like so, and it would actually change that array to the squared version. So not only would this original array change, the return value would actually be the initial array. So essentially we don't actually get a return value, it's just the same array we passed into it. And this is certainly for Redux and React a bad thing. We want to not mutate our values, we want to have new values so we can be certain of the changes that have occurred. So remember, pure functions have a predictable outcome and they don't mutate their values, they create new values. So it can be said that pure functions do not have any side effects, and that you can always be sure the result will always be what you expect from a pure function. So let's take a look at reducers. So when an action is emitted, it goes to a reducer. And reducers are essentially a big switch statement that does something depending on the type of an action. So if you remember, I said that the only required property on an action object is the type. And the reason it's required is because it gets sent to a reducer, and that reducer does something depending on that action's type. And reducers take our current state application and the action. They then return the next state. And if you remember, the next state that gets returned is a new object, as we don't mutate the existing state object because we are using pure reducers. So let's have a look at what a reducer looks like. So again, I'm going to use some ES6 here. This is an arrow function. It's essentially exactly the same as a normal function. It's just a much nicer way to write functions. So our reducer takes the current state and an action. We then have a switch statement, and we switch on the action dot type. So if you remember, let's write our action out again. So we have our type, and it's add project, and we have our project. Let's go for build Death Star, and we have our goal of $999. So our reducer takes our current state, so our two projects, our project array, and the action that is emitted. And in our case, it's an add project action. It looks at the type property on the action, so in this case, add project, and then it does something depending on that type. And of course, you determine what happens. So for the case of add project, we want to do a certain thing. In our case, add the project to our state. So rather than doing current state dot push project, not project, action dot project, for example, we don't do that obviously because that is mutating our state, and we don't do that because we're using a pure reducer. So what we do instead is we create a new state object. So have a constant, and we'll call this our next state, and it's going to be an array, and it's going to take our current state. This again is some nice ES6 here. So all this means is we essentially just taking the entirety of this current state object and placing it here. So this will just take these two objects and place it into the array like so. And we're then simply going to add on to that our new project. So obviously we would determine what the ID is. Obviously we know it's going to be 3 because this is a really simple example. We then have our project, which would be action.project. And we then have our goal, which would be action.goal. And we then of course have funded false. Because obviously when you first add a new project, it's not going to be funded. We then simply return that next state object. And of course we need to have a default of return our current state. So if we were to have another action, for example, a type of delete project, we would of course just have another case statement. So we would have case delete project, and then we would obviously have a new state object. So we'd have const next state, and within that we would delete the project, and then we would simply return that new state object. So you can see that very quickly within our reducer we're going to have lots of different cases for handling different actions. So now we know about reducers, let's take another look at the lifecycle. So we still have our UI, and that obviously has handlers which emit actions. Those actions get dispatched to our reducers. Our reducers then take our current state and the action. They then do something depending on the type of the action, and they then return a new state. This new state then gets sent to our UI where it's rendered. The user then makes another request, so we get a new action emitted, which gets sent to our reducer, which creates a new state, which becomes our UI. So now you understand a bit more about actions, reducers, and state. We can actually start to write some code. And as you can see it from this diagram, it's actually quite simple once you understand what's going on. It's quite a smooth life cycle. Your UI has handlers which emit actions, which get sent to our reducers, which create new states, which get sent to our UI. So now we've covered the 3 fundamentals. We have a single source of truth, our state is read-only, and changes are made by pure functions. It's time to write some code, and that's exactly what we're going to do in the next video. We are going to create some actions, a reducer, and some state in a plain JavaScript application. It's going to be nice and simple, but you're actually going to be able to apply everything you've learned from the 3 fundamentals, and it's all going to make absolute sense. So thanks for watching, and I'll catch you in the next video. Don't forget to subscribe, like, and comment.